I'm a CJ, I'm with Asyril. So we are the flexible feeder component of this. So a little brief about Asyril. So flexible feeding is taking components in bulk, separating them for robotic pick and place applications. The traditional way of doing that is bowl feeding, but those are really designed for one component and one component only. If you want to switch over, make product changes, or switch products over, requires retooling of the bowl. The benefit of the Asycube in our products is the ability to add flexibility to your automation line. So you can be running one part for a shift and then easily change over to a different SKU that ends up going through the same process. And so what we've got here is we've got different colored gears with different amounts of teeth on those gears, and we're able to separate them, and then we're able to use our camera system here to be able to image, identify how many teeth are on the gear, and then pick them with the robot. And so typically, your operator would come in with bulk parts and then just dump them into the hopper here. And then the hopper here feeds bulk parts into the Asycube for separation. And it's all tied together with our camera. It's more of a control system. And so the camera does all the things that you need from a standard pick and place vision system, and identifies correct orientation. In this case, it's identifying how many teeth are on the gear, but it's also actively monitoring the fill level of the Asycube as well as the position of the parts on the Asycube. And so internally, it's able to tell the hopper to feed on more parts. So if we pick 10 parts, the hopper will vibrate to feed on 10 more parts. And it'll also automatically center the parts on the Asycube to be able to minimize any dead space. And so with all of that tied together, it creates a really easy to use system for pick and place. So very nice. Turn it over to the robot.
My name's Cade Webster. I'm the automation specialist at Igus. We provided the cobot that you see here. So ultimately, this is our 6DOF collaborative unit. It is, in this application's context, the means to move these components from the feeder system to the camera and then their respective ending locations. And this is sort of what you might see in a variety of applications. A 6DOF is the most flexible arm that we offer. This one's sort of an entry-level unit. It comes at a very affordable price tag. The main benefit is the price tag. Comes in around $6,800. So especially for those that are getting into automation for the first time, you need a collaborative unit, you don't want as much safety, and you want something that's easy to program. This is a really nice place to start out. Of course, we have faster, more industrial robots. The throughput can be increased with a faster robot. This is just a very nice and flexible system, allows you to manipulate parts in a variety of ways, and it talks very nicely to the Asyril system and the Keyence system, respectively. So.
Awesome. My name is Aaron Westman. I'm with the Machine Vision Group at Keyence. I'm sure many of you are familiar with Keyence. Keyence makes automation and inspection equipment. I am smack dab in the middle with an automated inspection system. Our cameras do many different operations. I mean, you saw some of the pick and place stuff that the Asyril can do. I mean, that's in our wheelhouse as well, but generally I live in the inspection realm. So, defect detection, position adjustment. We do vision guided robotics as well. What we have here is our smart camera. What that means is that the processing happens on board. You can also see that this camera has some built-in lensing. This allows the flexibility of working distance and field of view. And you can also adjust that on the fly within the program. So we have a lot of flexibility there. And a lot of the times with vision, some people are wary of it. It comes down to lighting and lensing. We have a whole variety of lights and lenses available as well. So a lot of the times, when vision comes up, I'd say give us a call, give Lehnen a call, and we'll take a look at it. We'll see what we can see and take it from there.
Cool. I'm Ryan. I cover our PLCs, HMIs, and servo motors. Basically, the PLC here is kind of the marriage between the three devices. We have our Keyence VS Vision system, the Igus robot, and obviously the Asyril feeder. We have an abundance of communication protocols that we can use on this PLC right here. Keyence to Keyence devices is very user-friendly. We have all the EDS files saved for any Keyence sensor in our software. We're connected over Ethernet IP to our camera here, as well as the Asyril feeding system, and then Modbus TCP for the robot. Little background info on the PLC. So for those who didn't know, we've been making PLCs for about 40 years now. We brought it to the US only 4 years ago. So this is our brand new KVX 500. Came out just in September. Couple unique features that you'll see today is we actually have a web dashboard with this data collection unit. This camera up here on the mount, the furthest one up, is actually used for live monitoring and recording. So we can see a live image of what's happening on your machine process, and we can tie that into the ladder logic. So that is completely unique to the PLC world, where we're tying in the ladder logic from a machine, whether you're capturing a fault, any machine issue, and now we can play that back in real time.
Cool. Without further ado, we run the system.
So here we're using the Asyril system to be able to separate gears. There's a number of different defects that we've also added to each gear. So it's not really looking for color at all, but it is looking for defects. So there's off-centered holes in the middle. There's either missing teeth or I guess double teeth. The Asyril system will just pick based on the number of teeth, provide the coordinate to the Igus robot to pick, and then the Keyence vision is presented to part and then identifies color as well as defect and then sorts based on that. And so, yeah, I mean, that's...
Yeah, I could talk more about the Igus's robot involvement too. Admittedly, its function is quite simple, right? Robots don't come with eyes or ears or fingers to touch and feel. Some of the underrated qualities of being a human is we can immediately perceive what's in front of us. So thanks to the Asyril and the Keyence system, Asyril can say, hey, I've got a gear here that's ready to be picked, and the robot can go accordingly. And the Keyence can say what's wrong with the gear and where it needs to go. So.
Exactly, yeah. So, as you just mentioned, right, what's the Keyence vision doing, right? It's looking for those different defects, and it's classifying. We have all these different cups here. So when we were testing this before, we had the beaver teeth, right? That's the kind of the conjoined tooth. We have the affectionately named Strahan tooth, which is the missing tooth, and then we have the miscentered, center bore there. So again, Keyence is looking at that, and we have a few different tools there, right? So we have AI tools we can use to classify these. We have blob tools or edge pitch tools that we can use to count the number of teeth and sort defects that way. Again, very flexible system. It really just kind of depends how you want to approach the program.
I think
not 100%.
Excuse me?
That speed is not 100%.
For this one, so collaboratives need to move at 250 millimeters per second. That's an ISO standard. I think ISO has recently reclassified collaborative to collaborative environment appropriate. So yes, this robot's running at 100% speed simply because it needs to operate in an environment without safety or alongside people. We have a ton of different robots, and you might actually notice on your invite, there's a 4DOF SCAR robot. Those can really whip around, but those can also hurt you. So generally they are in a locked environment. If you need higher throughput, that's definitely an avenue we can pursue, right? There's a million different ways you can part sort, you can quality inspect. This is just a collaborative way of doing it. So if you wanted to crank up the speed, you absolutely could.
So you're passing the coordinates from the Asyril to the cobot?
To the PLC.
Yeah, so it's like somewhat coordinated. So how are you establishing like a good datum of reference between the robot's home position and the coordinate passed by the Asyril? Is it just a one-time taught?
Yeah, so there's a hand-eye calibration that gets done within I+. So it's a 4-point coordinate system. So you train a vision recipe of your part, you pick it with the robot, and then you place it down in one of the 4 corners of the Asycube. You tell I+, hey, this is my XY coordinate of the part, and then you remove the robot and take a picture and localize it within the vision system. You do that 4 times, and then I+ is able to essentially map out, okay, where is my Asycube in the robot's frame of reference, and then when it passes on those coordinates, it's already in the robot's reference frame to be able to go and pick to. I'm not exactly sure how Aaron had specifically set it up. I think you used user frames?
On the robot end.
On the robot end?
That was to compensate for the face of the robot not being perfectly parallel with the Asyril feeder.
Gotcha.
Is there a limitation on how fast you can transfer data? So if we're trying to track something as it's moving to pick up, how fast can you transfer data?
So I guess that kind of depends on the communication protocol. Natively, I+ communicates via TCP/IP. I find socket messaging to be a little bit slower. Otherwise, we've got integration with Rockwell Allen Bradley PLC's Ethernet IP, Beckhoff, which is EtherCAT, or Profinet Siemens. That seems to be a little bit faster, a little bit easier to integrate into higher speed environments.
Just normal applications, you guys aren't having like parts on a conveyor that you're picking up that are moving. It's shifted out in still position, picking it up from that.
Yes, currently, yes. We do have plans to introduce some additional features within I+ where it is a standalone unit to introduce into conveyors, but that doesn't include conveyor tracking currently. But it is in the works. I don't know if Keyence offers conveyor tracking vision systems.
No, we prefer kind of, static, yeah.
Okay. There are vision systems out there that can handle that, though. Yeah.
Is it okay that we're asking questions?
Yes. Yeah. Please ask away.
Can you speak a little bit to how the Asyril, like there must be an algorithm or a recipe or something. I imagine there's 3 or 4 axes that are vibrating to try to gather or declutter.
Yeah, absolutely.
How does that work? Is it recipe configurable?
Yes, it
Do you
is.
have to kind of teach the part as an auto learn, or is it kind of a intersection of art and science?
It's an intersection of art and science. So there are 4 actuators in each of these corners, or there's 1 actuator in each corner, 4 total. And that's how we're able to move the parts around, is based on how those actuators are firing. And so within your recipe, I mentioned that I+ does all the vision stuff, but it also manages the Asycube movements, the vibrations and everything. And so you have full control over the amplitude and frequency at which this is vibrating. So a forward move would actuate these 2, and you'd move the parts forward. Backwards would actuate these 2. You can also go left and right. And Asyril has a patent on that. We're the only flexible feeder company that can move in all 3 axes, forwards, backwards, left, right, and flip. And so we're able to maintain full control over the parts at any given time on the Asyril system. And when I+ takes a picture, it's actually calculating the center of pixels of the parts. And when you go in and you do your recipe training, you're essentially telling I+ how long it takes the parts to vibrate from one end to the other. And then internally, I+ will take a linear relationship between where that center of pixels of the part is versus how long it takes to move from one end to the next so that it can center those parts. It's going to vary based on the part. There isn't an auto-tuning setting yet. It's something that we've looked into, but it's a little bit difficult to do because parts behave so differently, right? Plastic gears get those vibrations translated to them a lot better than, let's say, rubber or silicone parts. Those absorb the vibrations pretty extensively, and so having that, I guess, human art form allows it to be a little bit more flexible and easier to program, more consistent. Does that answer your question?
Yeah, I think like if you want to descramble like a clump of parts, are you just vibrating it and they naturally tend to separate?
Yeah, so that would be like a flip move. So all 4 actuators firing simultaneously, no phase offset. And that spreads the parts out. And so depending on your frequency and amplitude of parts, you'll be able to either excite them a lot. You can eject parts out of the Asycube. That's not ideal. But you can also make them...
Yeah, when you're saying flip, you mean like flip like this?
Yep, yeah.
I was going to ask about that. Like a lot of parts that we handle aren't short in one dimension, right? They might be laying on their side and they want to flip them up. So can you speak to performance with that?
Yeah,
It's kind of like, flipping a bottle.
Yeah. So we do design custom trays. So this is one of our standard ones. It's an anti-roll tray. It's got pyramid structures on it to allow for parts that are kind of cylindrical or circular to rest. If you drop a coin on the ground, it's going to start wobbling and rolling a little bit. This anti-roll tray stops that. But what we can also offer is custom holes to encourage parts to orient vertically, like long cylinders or tubes. We also have through slots useful for, let's say, screws. Something where there's a shoulder to be able to rest those parts on. So we're able to kind of work with you to design a custom platform to be able to orient those parts. You know, depending on the part length and size, it can get a little bit tricky. There is obviously a depth to the backlight that needs to be respected. Otherwise, picking horizontally and regripping with a 6-axis robot or some sort of dead nest to regrip from is always an option as well.
Sorry to interrupt. This feeder lives here, so if you guys want to experiment with anything, you know, you just bring it over, and they can create custom, what do you call it?
Platforms or trays.
Yeah, so we could also coordinate that so that you could evaluate, you know, anything very easily.
Yeah, and Lehnen's a great resource here. I mean, they've got the hopper, they've got the cube, and they've got our vision system. We do also offer free feasibility testing in our US lab. So if you've got parts that are a little bit too large for this size Asycube, we've got one size higher. So this is an Asycube 380. The way that that's measured is from corner to corner like a television. So it's 380 millimeters. We do all the way up to 530 millimeters, and we're also looking at larger part feeding as well. That's in concept phase. We also go all the way down to 50 millimeters. We got our start in the Swiss watch industry, so we do a lot of small components, but we also do a lot of big components. And so that testing is free. You'd be able to work with the local distributor here to get a feasibility study started. That's free of charge. We would be able to design a custom platform for you if it was needed. We'd provide you with cycle rate analysis, vision analysis, and videos, and a detailed engineering report so that you guys know, does it work? What can you do? How can you achieve your cycle rates? All for free. So that's also a good resource. Otherwise, you know, like Peter said, this is a great in-person tool to be able to use as well here locally. There are weight limitations. Shape limitations, it kind of depends, obviously. I don't know the weight limitations off the top of my head. I want to say there's 2 kilograms for the 380. The 530's got a little bit larger of a weight limit, but these two, our two largest sizes, are going to have the higher weight limit. It's just based off of the technology, the actuators that we use in the smaller sizes that creates limitations. But that's all in our documentation. I can also look that up if needed. But yeah.
What's the maximum payload for the larger one?
2 kilograms, I think. I could get that for you. I'd have to look in the documentation, yeah. We don't typically see people reach that weight limit until they're feeding really large, like steel parts. And then even then, you know, once you reach that size of part, you're not really limited by weight, but more so the amount of parts you can fit on the Asycube in general based on the part size. I would say we can feed probably 90% of parts, even in their weird orientations. It's just a matter of finding a tray that works and working with you guys to find a cycle rate and robot that works as well. And again, we would be able to do that within our feasibility study testing as well.
This is a question for everybody. I know on the Keyence, you can get the software and you activate it for the hardware. Is all the software freeware, or do you have to pay for licenses across any of this? Like if I buy this arm, is the license included? PLC, you know, we're used to Rockwell, factory talk, we have to get a toolkit. Over here, does this come with the development program?
You guys want to answer first?
Yeah, I'll start out with the PLC. So our software is a one-time cost. It's $2,300. We're backwards compatible with every model that we've been making in the past 40 years. And that's unlimited users throughout your site and facility.
That's like concurrent users, like, or is it per, like you got to check out a license one at a time?
You buy one license and then you can distribute that passcode with anybody.
Okay.
From a vision standpoint, we have 2 instances where you would pay for software. One of them is unrelated to this system entirely. It's for our XGX, it's our controller-based system. It's not necessary, but it's good for offline editing. It's called our Vision Editor software. The other time is a recent tool that we've added to this camera. It's called AI segmentation, and that's a one-time cost.
Yeah. We're used to using the new VS
Nice.
series.
You're familiar with it.
Pretty good.
Have you updated to the latest 1.5?
It's been a few months, so I'd say no.
Well, let me know. I can help you update it, and we can check out some of the new features.
Robots perspective. The Igus robots, including the cobot here and the little Cartesian system back there, software is always free. You don't need to buy a robot to get it. So you can actually mock program in a virtual environment the robot to see if it'll meet your speed requirements and to see if the motion works, if you'll hit any singularities, etc. We do carry some other robots. Epson, that's free software as well. When you buy the robot, it comes with a controller. Most of the units that we sell, it'll be free software with the controller. That's a pillar that we stand on.
And then, yeah, from the Asyril standpoint, you buy the controller, you get the software for free. So I+, it's all software is contained in there. This is actually using one of our additional software options called multi-model, where you can train up to 6 different models. So they could add, 3 different sets of tooth gears, and that's a one-time fee. It's per controller. And then we've also got what's called multi-feeding. So let's say I wanted to feed 2 different parts into the same Asycube, but have a separated tray. We typically see that for like assembly applications. You'd pick one part of one of the other. They're all on the same cube. That's also a one-time fee per controller. You get that for life. I don't know the cost on that, but it's pretty cheap. But all of the other software, like standard stuff, would be free of charge included. So no software as a service here, it sounds like. So.
I think it's the way of the future. I think the old model of holding you captive, to this endless subscription in order to, maintain your equipment and stuff like that, it has to go. And everyone that, including Beckoff, who's one of our partners, that's the model. You pay one time upfront. After that, development support is all available, at no cost. And I think that's where the industry has to go.
How many recipes can the Asyril handle?
It's not so much a number as much as a file size limit. So there's an internal storage. I don't know what the internal storage is off the top of my head. Personally, I haven't seen anybody hit that limit. We do offer FTP servers as well. So if you want to, store your recipes on an FTP server, then it's as big as you want it, right? So you can just pull those from your server and include those. So I would say unlimited, but I think it's like a 4 or 5 gigabyte internal memory. But I could look into that for you. Pretty big though. You can store quite a few on there.
Could you add the FTP option after the fact, or would you need to?
No, it's free. It's just a part of the software that you can include. So we don't sell the server, obviously, but if you guys were to install one, you can just connect it to the server itself, and then all those recipes can be loaded onto the server. You can edit them within the I+ controller software. So it just pulls from the cloud. It'll save to the cloud, and then when you actually start production, it's just pulling from that server. That's what we do for our office, because we do so many feasibility tests rather than having to save them locally and then clear out the controller every now and then. We've got an FTP server so that all of our feasibility recipes are backed up on a server, and then we've got hundreds and hundreds of recipes. So.
Would, say you have 4 cubes, would one recipe translate well to the other 4, or would it be you gotta keep each recipe?
So if you're running the same parts on there, the vision recipe and vibrations should translate pretty well. You can download those from one I+ controller and upload them to the next. So it is one controller per cube, and then you could just download that recipe and upload, and it would likely work, I would say, probably pretty well, as long as the ambient lighting is similar. The biggest thing is how the Asycube is actually mounted. It needs a pretty solid mass under it. I mean, these actuators are pretty strong, and so you want to make sure that all of the vibrations are going into the parts and not, the table itself and shaking everything around. And so if your mounting changes a little bit, you might want to touch up the vibration profile a little bit from part to part. But if it's 4 cubes, 4 same parts, ambient lighting's the same, you can probably translate that pretty well to the system, to each system without any changes needed.
How do you load a recipe to be like the active recipe? Would it be able to be smart and hey, this part's in here, I'm gonna run this recipe, or you gotta
So
give it a job number?
you have to give it a job number. So each recipe is generated with a unique recipe identification number. And so you essentially just say start production of this recipe ID. There's some, I guess, workarounds to validate what recipe is active, but it's all software and programming kind of, I guess, tools. It's nothing within I+ that can do that currently.
You program in the recipe like a pickup barrier, so you can't get too close to the wall?
Exactly, yep, so that's in the last step. So you program your end of arm tool exclusion zone. So this is using a vacuum tool, which is nice because essentially everything that is separated from another part is pickable. But let's say you had 2-finger or 3-finger grippers. You would just enter in the dimensions of those fingers, and now if there's another part overlapping where your end of arm tool would go, that part would no longer be pickable. You also bring in the edges of your, I guess, region of interest or your working zone to ensure that your end of arm tool has enough space away from the walls so that it doesn't collide as well. And so any part that is inside of that, I guess, frame exclusion zone would also be deemed unpickable. So that's all able to be set by you.
And actually, in doing this, sorry, I'm Nate. I work here at Lehnen, and I helped set this all up to start with. When we drilled this and put it onto the plate over here, we probably put these two just ever so slightly too close together, but not far enough that there is actually adjustability in the feeder base back here, but I didn't want to go back to the next setting. So we actually have the exclusion zone probably 3/4 of an inch in over here or whatnot, just so we don't accidentally catch the lip of that. Something we would get right if we were taking this into production, but from a standpoint of doing a demo, we restricted it, and maybe it's got 2 or 3 available parts here or there that it could have picked otherwise, but it's not slowing down the demo today.
You get some outputs out of the Asyril, let's say like no parts are pickable, flagging, hey, we need to load up some more product.
Yeah, so when I+ takes a picture, it loads all of the good coordinates in a queue of good parts. And so there are some variables that you can request, like how many parts are available on the Asycube to pick, so that okay, let's say I+ responds with 6. Now when you pick 6 parts, the Asycube needs to shake, the Asyfill needs to feed on more parts after that vibration. And so you can, pick, and as soon as you leave the camera's field of view, trigger that vibration sequence to happen so that by the time the robot places that part and is ready to pick another one, there's already parts available for picking. There's some additional parameters that you can read and modify in our documentation. There's timeouts, so like if I+ is vibrating and it doesn't find a pickable part after that vibration, it'll automatically trigger another vibration sequence to happen. And then after 30 seconds, it'll automatically time out and provide you with an error code saying, hey, I tried for 30 seconds to find a pickable part. I couldn't. This is the error code that I found. You can modify that timeout as well. You can lower it. Let's say you want it to be tighter to know, hey, I'm not picking parts after 15 seconds. Or you can disable that timeout entirely and say, hey, I don't want you to time out at all. If you don't find a part, keep going until you find one. We've got a pretty detailed online documentation as well that kind of goes through some integration examples, all of the available outputs and commands that you can send to the I+ controller. We also have EDS files for all of our field bus communication protocols as well, so that you can just download and integrate those into your PLC project, along with sample code as well. The goal is to try and make this as easy as possible, because everything else that's going on in your automation project kind of probably wants to take precedent. I mean, feeding is only one small portion of the whole goal here. And so we pride ourselves on ease of use.
What's the cost of the system?
It really varies depending on size and, I guess, add-ons, but I would say roughly 30 to 35 for hopper, cube, and camera system, all said and done.
6,800, so 6,800, which, as far as robots go, it's on the very low end of the spectrum. You can get very, very fast industrial robots for anywhere from 20 to 70,000. So, like I said, very entry level, and this thing is also all plastic. So, Igus is a plastic company. We do all the injection molding ourselves. So that's the reason for this robot's creation, is to be a starter point.
On the vision system, lighting, proximity to parts, or part requirements like an opacity or something like that, bringing the background if the part has translucent.
Absolutely. So the fun part with vision is that anytime you have a question about a part, the answer is almost always it depends, right? You know, how are we presenting the part to the camera? What are you looking for as far as the defects go, or is it just a position adjustment, right? So the answer is almost always it depends, right? But the good news is that, I mean, what we have here is like kind of a standard we call it torch light or smart light, just fixed on the end of the camera, right? We also offer backlights. We also have ring lights. We have low angle ring lights. We have specialty lighting that, you know, the example I like to give is if you have a scratch on a CD, what do? You kind of hold up the light and you rotate a little bit. We have that same technology. Instead of moving the part around the light, we move the light around the part. Call it like 2.5D vision. Like we're able to bring out surface defects or features that would be tough to see otherwise. So again, short answer, it depends. Long answer, we have lighting that can suit most of your needs. Translucent parts are difficult, right? But again, I don't want to count myself out too soon, right? I'm always happy to take a look at it.
And to kind of bounce off of that, as far as the Asyril vision, we've got backlights here. We do offer front lights from FLX. So if front lighting is needed, we also do a lot in the med device industry, and so we know that translucent parts are pretty tricky. So we offer polarized plates as well to try and make those translucent parts pop. So you know, it's a good thing. You know, if your part is pretty tricky or you think it's going to be pretty tricky to see, we're always willing to take the part, do free testing for it as well. But yeah, it always depends part to part. So.
We never tried any clear in setting this up, but somewhere I'll find it when we're done here. There's 10 more colors worth of gears around here that we played with in setting this all up, and we actually found the vision inspection camera to be capable of, we actually had a white background at that point in time, but we had white, yellow, these orange gears, as well as a really deep navy and a black gear. And we were actually able to dial in the vision system to be able to detect all of them, which honestly was a very pleasant surprise at the point we were able to pick up the white on white. You know, the black on white nobody was surprised by, but but at the end of the day, we didn't want you to think that we're up here only looking at the color of something to put it in a cup. So we backed this back down to 3 colors again, so you're genuinely looking for the defects that exist in these gears.
And speed of detection, if in this case the parts are moving underneath the camera, rate pretty fast?
Yeah, so kind of, again, it depends. So obviously we want the parts to be settled before we take a picture. Vision analysis typically ranges from 300 to 500 milliseconds, and then stabilization time depends on the part. But again, that's why we have this anti-roll tray here, is to try and stabilize the parts as fast as we can. So from the time of vibration to stabilization time, I typically find around 850 milliseconds is the time it needs to stabilize, and then a 300 to 500 millisecond image analysis time to be able to start picking parts. But I+ is kind of cool in the sense that when it takes a picture, it starts its analysis in the middle and then spirals out. And the moment it finds that first good part, it sends that coordinate right away before it's even done analyzing the rest of the picture. And so while you have that part coordinate, it's going through the rest to analyze and store those parts in a queue. And so you can be picking while it's still finishing up image analysis if cycle time is really tight for you.
Yeah, I'm gonna piggyback on that as well, right? It always depends, right? For us, as far as tracking a part on a moving conveyor belt, we can do it. I know I said we don't support like robot picking from a conveyor belt. We've had customers do it, right? I mean, if we can track a moving part and we can take a picture of it, right? As long as that shutter speed is low enough, it'll appear stagnant to us, and right at that point, the customer will have to do the math to figure out, all right, what's its speed and can I grab it in time? But as far as our inspections, right, it takes anywhere from, again, that capture can be less than like a millisecond, or it can be, 100 milliseconds if you really need that exposure big enough. And then, again, it depends for the inspection itself. If you have 1 or 2 tools, I don't expect that to take longer than, 30 to 50 milliseconds. But if you're doing multiple AI tools on one camera, yeah, that cycle time can get up there, and now you're pushing, 500 milliseconds, Again, it depends, but, same idea, right? Always happy to do some testing, kind of.
And we could have sped this up too. I don't know if you just caught the robot paused right here and then the Asyril went and did its shake. That's how we have it programmed right now. The Asyril knew, I don't know, 2 minutes ago that it was going to get 7 parts picked or 8 parts picked or whatnot. It probably could have, we could have had it programmed so it would have done the shake while the robot was over here presenting. But we're using a cobot, we don't have guarding, nothing's moving fast here, so we didn't optimize that. This isn't a high-speed production line right now. But if it needed to be, the Asyril would have done its shake, photo, send coordinates while the robot was coming back to it instead of sitting there waiting for it to happen.
What's the repeatability on the cobot?
This one's a millimeter flat. So as far as precision is concerned, compared to the market, right, everything's relative, it is probably one of the least precise robots that's available. You'll have some that are sub-millimeter, some that are into the tens or even single micron level, which is crazy. But not to beat a dead horse, it depends on what you need. Yeah. So.
Is this the only size of this robot?
For this collaborative, this is the only size. We make Cartesians, Delta robots, non-collaborative robots, SCARAs, and those come in a ton of different sizes, but for right now, this is the only size collaborative we have. If we get enough requests like yours, we'll probably develop more.
There is you have some brochures back here that shows the whole lineup of motion components that Igus has, so you can cruise through that.
I would say our mission is always the lowest cost solution that functions for the application, right? We want you to save as much as you can and reach ROI as fast as possible. So, and if you want to talk more about different robots, we'd be happy to, right? There are some that are blazing fast and there are some that are very slow.
What about maintenance and longevity?
This guy? So there's no maintenance per se. You don't have to grease any joints. You don't have to attend any gears. Each joint has been tested to 1 million cycles, and there's formal data to back that up. Most conventional robots will have a predictive maintenance schedule, though. So you need to go in and you need to touch up the brakes. You need to add some stuff here. You need to check the repeatability. As far as this one is concerned, though, you'll let it run until it throws an error, and then we'll come in and support.
Does the Asyril require any maintenance?
There are some items that require maintenance, but it's really, so there's ball joints here that are, I think it's, I don't want to speak on the actual maintenance schedule. It's really long. We have Asycubes that have been in production since we started, and really the maintenance is most commonly just actuator replacements over the course of failures. Like years, we don't really see many actuators fail within the first 3 years, I would say. But as far as replaceable parts, I mean, there's not too much moving here. And so the maintenance is pretty low. And those maintenance items can be done by your technicians there. It's electronic repairs that would need to be done by us. But we're able to do those repairs here in the US. So Asyril is a Swiss company. All of our products are made in Switzerland. But a lot of the repairs can be done in our US office in Minneapolis. So you just ship us your product. We'd be able to do the repair and turn it around and send it back to you.
And these are voice coil actuators.
Yes, they're voice coils.
So it's not a mechanical, it's not a purely mechanical part that's going to have all the standard mechanical wear methods to it. So you're dealing with something that doesn't have a lot of time wear out mode or wouldn't wear out.
Mm-hmm. Yeah, exactly.
Can you guys speak to availability of your product? Like, what's the lead time on on feeder the robot?
All of our standard products here, so everything that you see here is 5 weeks, I think, right now. Custom stuff, it gets a little bit longer. It's shipping from overseas, but everything here is standard 5 weeks.
Standard parts from us, like a standard robot like this or a standard Cartesian in the back, is 24 hours to ship. We're a German company, so a lot of manufacturing is done in Germany, but we've brought a lot of it stateside within the past 2 years. So 24 hours for standard parts, 4 weeks for custom parts is a good benchmark.
For Keyence products, our lead time is about 2 to 3 business days. Our warehouse is in Chicago. Also, I don't know if we mentioned, but our support is all free as well. We have a tech team out in Chicago, and then we're a local rep.
One thing that, if you could elaborate on the PLC and the monitoring and just what's you touched on it, but it's so unique that I think the audience here would really be interested in understanding more detail about how, when it's the first time I've seen this, and I just think it's really neat that if you're troubleshooting something, you may not know what happened first when there's a failure. And I've done a lot of troubleshooting over time, and I know something happened, but you're not really sure what happened or what caused a cascade of problems. So this is so unique that you're watching your machine with a camera, and it's constantly keeping a video record. Now, correct me if I'm wrong, it's a first in, first out kind of thing. So there's a certain time buffer where you're recording everything the machine did, and then you can use their development tools to look at what the signals were as you're looking at the visual image of what happened. And so I'll let you take it from there, but I just think it's something worth elaborating on because it's really fun.
Yeah, so this is a very unique PLC. It has a lot more compatibility than just your main control on a machine. Starting with the camera, so we call this a machine operation recorder. You could think of it as like a Ring doorbell or a dash cam in your car, and essentially this camera is constantly recording your machine process. Now, when you have some sort of fault or machine issue, we have a trigger that will say, okay, we want to record up to 10 minutes backwards before that fault happened, but it's actually synchronized into all the ladder logic. So I'm seeing any bits turning on and off. I can capture arms, any integer data, analog data. We're capturing all of that, throwing that into a trend, very similar to like a trending tool in Allen Bradley, but now we have the video footage synchronized to that. On top of that, we also have the second module from the CPU to the right. It's called a data collection card. And essentially what this does is this has AI in the system that will learn your machine process. So we'll set it up, and we can actually use this as an add-on with existing PLCs and controllers. We'll set this up, and we'll let a machine run for about 10 minutes, at least 3 to 5 cycles. And all we're doing is we're learning all the process time. How long does it take for the rising edge and falling edge of this bit? Different cycle times, capturing all that data, and now we're using that as a comparison between any issue or fault that we capture from here on out. A couple other features that we'll use this PLC for is data collection. So whether that's monitoring OEE, cycle time monitoring, as well as connecting to like an ignition server. We have OPC UA server on the CPU right here. We have an abundance of communication protocols. So connecting to Allen Bradley PLCs, for example, our ratio is typically going to be 1 to 4 Allen Bradleys, where I can throw 2 cameras on each one, pull in the tags pretty easily, set up triggers for each one, and start monitoring what's happening. We can set up a web dashboard on the iPad right here, where you can see the live camera as well. Any questions on, kind of how you would utilize this system?
Is there a limit to how many tags you can buffer? So you're recording like the last 10 minutes of video or something?
Yep, so it's 1,024 per PLC.
Tags or bytes?
Tags, 1,024 tags.
Are you able to do it with the alarms, like say any alarm, or are you actually putting tags in and monitoring certain outputs or whatever?
So both. Typically how we'd set this up, if you were to troubleshoot an Allen Bradley PLC, So we have a custom feature called PLC Link. You select the PLC that you'd like to connect to. There's a whole drop down of models. Type in the IP address. We hit a read tag button, and you have 1,000 tags in less than a couple seconds. From there, I would ask you, hey, what relevant tags are related to the issue that you're seeing? Are there alarms that we can use as triggers? Or you can go into Studio 5000, create a different bit that is now used as your trigger. The third option would be we can put a record button on an HMI. So an operator, so even on your panel view, you can put a record button on there so the operator sees that there's a fault. They go hit this button. Now we're saving on an SD card the last 10 minutes of data.
Yeah, this is like really useful tool for
Yeah.
startup.
Yeah.
Especially, we're doing work for a plant we just built in Ireland. So we're doing remote work, remote controls support, and we're trying to,
I can
interrogate
remember this.
people. What just happened?
It's incredibly useful. I was really excited when Ryan brought this in for the first time 6-8 months ago or whatnot. I started my career in nuclear power for, 12, 14 years. Even though a lot of nuclear power plant technology is pretty old, they're pretty darn well instrumented feeding into a plant process computer. If we needed to chase something through, I've got tens of thousands of data points that are being collected at like 10 milliseconds or something like that. You need to figure out what's going on somewhere. You can pull it up on your screen and you've got more data than you know what to do with that's all aligned and you can look through it. Now, we didn't have a camera looking at something necessarily, so I couldn't look at it. Now, of course, if you're talking about flow of water in a pipe, what would you put the camera on anyway? And then after leaving nuclear power and going into other manufacturing environments, like, where's my data? Didn't exist. So now you can integrate it with the PLC without having to take any sort of extra steps to have a standalone process computer and programming and to do all these things. It's really conveniently built in. With my background, I was just so excited to see that even.
I mean, I've seen other stuff on the market, but same thing, you gotta wire it in, whatever else, like Hindsight 2020, I think was one of the versions there. And we use it all the time, it was great, but this makes it so much easier. You can literally, now that everything's networked, right? I can just, I'm having a problem with this machine, I don't have to be there. Right? That makes it, I think, really powerful.
What's the cost on the bolt-on video unit?
So basically to use the camera system, it's all controlled through the CPU, so the PLC itself. The PLC itself is around $2,000 to $3,000. And then depending on, maxing out the system, let's say you're doing a whole data collection card, 8 cameras, you're looking at like the 15K to 20K range. A very base system, maybe 1 camera, anywhere from 4,000 to 6,000.
Okay, so you need the PLC with it. It's not
You do, yes. So, like I said, very unique PLC. We could use this as a main controller, and now the advantage is, you go put this on a machine, now you're recording everything. Think about, you have multiple machines in your facility with this as your main PLC, you're capturing all that data. On the other hand, we can also use this as an add-on. So the 2 different scenarios that we see typically as an add-on PLC would be, one, we call it a crash cart system, which is like a mobile troubleshooting case for a maintenance or automation engineering team. And they kind of take it around to different machines that they see having faults. And whether you're leaving on it for a couple hours, couple days, couple weeks, just to monitor any issues that you're seeing on those machines. Or 2, a permanent add-on solution, whether that's bringing in any data collection and setting up a web dashboard that you can see in a remote location for OEE analysis, failure analysis, live imaging and monitoring.
What's the scope of work look like if you were going to make it a main PLC and you were going to replace like a Compact Logix or something?
So we actually just came out with a program conversion tool a couple months ago. So any L5X file, so Compact Control Logix, you can actually, once you have our software license, we have like a Dropbox converter, drag and drop the L5X into that Dropbox converter, and Keyence will convert, or our Keyence converter will take it to about 95% of the way there, which saves a lot of time. Our software is IEC compliant, so if you're familiar with Studio 5000, it's very similar to that. We have most of the same instructions. We also have a search bar or a toolbox, we call it, where let's say we didn't call something the same instruction, let's say like input XIC. We call that LD, but if you were to type in XIC in our software, it'll work no problem.
You guys have any safety controllers?
So we do not have a safety PLC. We do have a safety controller called the GC1000. I don't know if you guys have messed around with any of our safety before, and those integrate very well together. We have, custom HMI screens for monitoring light curtains, as well as interlock status.
But they all work real well with this because you guys have all the candid EDS files.
Yeah, exactly. So any Keyence sensor, I don't know how long that list is, but it's a lot of scrolling in our software. Any Keyence sensor, you drag and drop, all the EDS files are saved, and then the bitmaps there, everything's auto-mapped with commented descriptions of what each tag or bit is doing.
Just to interject, we've standardized on the GC1000 now, so all the equipment we're building for you guys right now has the GC1000 in it, and also they have probably the coolest latching door interlocks now, which are I think we have some out in the shop but they're RFID, and they use magnets rather than physical keys, and it's a whole new generation of door interlocks that work so much better than the old mechanical type and stuff. And they work with the GC1000, which is fully programmable and has Ethernet communications and such. And so it's definitely a new way of looking at safety interlocks, and they've done a great job of designing some innovative products in that respect. So,
Yeah. And like a development program for the PLC, can you do the same type of functionalities? Like we typically have large objects, large UDTs, add-on instructions. We develop our own, or our integrators develop their own.
Yeah, so
we have all the equivalent.
100%. So yeah, add-on instructions, we call them function blocks. If you do have specific add-on instructions that you've custom made, you can drop those into the converter as well, so you don't have to take the time remaking it in our software. You bookmark them, and then also in that search box tool, I think I was messing around with some of the Lehnen guys here with our software, but in that search box, it's an immense amount of function blocks for motion programming, any arithmetic, pretty much anything you're doing, it's already there. We also have sample programs as well that you can pull from.
So we have lunch ready, but I also wanted to mention that Igus is here, and they have a huge range of products that you guys might be interested in. So be sure to check in, and if you're interested in learning more about the beyond the mechatronics products in the huge amount of things from linear bearings, gears, cable chains, cable, all that kind of stuff. It's an opportunity to learn a lot about a very great product here. So, you guys want to finish up in any way, or you want to just head for lunch?
I've got one more thing I want to add. What you see here is one vision system that Keyence makes. I want to let you know that as the vision specialist, right, I support other vision systems as well. What falls under my purview would be 3D bin picking. We have a dedicated system that's been built for that. So you throw a randomized bin of parts in front of, or randomize one type of part, but you throw the bin in the camera's field of view. We take a 3D image and we're able to pick from a randomized bin. I also support line scan technology. So if you have a continuous web that you're looking to inspect, or if you have a round part that you need to unwrap and inspect 100%, that also falls under my purview. This is the smart camera. It's not that our other systems are dumb, it's actually that they're controller based, right? So the camera feeds back to the controller, that does all the processing. The advantage is that is you can hook up multiple cameras and they all kind of work in concert. So I know we said it depends a lot up here, and it really does depend. That's because vision is a very unique market. So basically any questions related to vision, no matter how simple or complex, I'm happy to be a resource, so please let me know. Thank you.
I think I touched on the PLC pretty well here. One thing I did want to mention, Just going off some of the safety that we were just talking about. Andrew in the back, if you look in the back there, he covers all of our safety products. And we also just came out with brand new light curtains just 2 weeks ago. So if you do have any safety needs, he's the guy to talk to.
I actually have the light curtains and the GC1000 with me in my backpack over here. If anybody's interested, go free, power them up, and take a look.
And this is obviously a great lab space if you did ever want to try out some of the features that I kind of mentioned on the PLC today, or even different devices. Here's a great spot to do it. I'm also local and I drive around with a test kit, so if you did have a unique situation or a scenario that you wanted to try out, I'm happy to come in with a PLC, a camera, and see what we can capture.
I definitely want to thank Lehnen. Probably the second or third most expensive aspect of automation is design, behind integration, programming, troubleshooting, etc. So this is really great to see a canned setup and a good example of how you might learn to sort through parts, quality check, feed, whatever you're trying to do inside your factory. Ultimately, again, just to reiterate, this is the lowest end of the robotic spectrum. It's a great crash course. It lets you cheaply learn the caveats and roadblocks to certain things. Pick this part in a certain way. All right, I can't do that. I can do this. Really nice crash course in robotics. And it's going to be here for a while longer, so please feel free to return to Lehnen. If you have questions about the robot, about other robotics, we can go a lot faster. We can go a lot slower. We can be really cost effective, or we can be very industrial, high throughput. So.
Yeah, I just want to thank Lehnen again. This is going to be here for, I think, a year or so. So make use of it if you guys ever want to come in here and test stuff. I know they'd be happy to help. And like I said, just reach out if you guys have any feasibility testing needs. More than happy to do free testing, work with you guys as well. So.
Yeah, and that's what we do. You can see around the room we've got a couple of other things set up that we've been working on. And truth is, we cleaned another 3 or 4 of them out of here that were just too ugly to leave in here and look at, and we needed the space and threw them back over there. We spent a lot of time figuring things out, tinkering, solving problems. I mean, as you've heard here, you see what this thing is doing, and you've heard that this equipment's all capable of doing more than it is right now. It's, when you're doing a demo like this, like, what do we want to demo? Clearly we invented a problem and then went about solving it. And come to us with your problems, and we'll apply what we have. It's tough to think of what problem does somebody really want to solve. So here's one made-up example and what you can do with it. Yeah.
And again, to iterate, this space is free to use. If you have a project that something you'd like to create, you don't want to try to, go to management to try to get funding for a development thing. Everything in here is completely free. Just let us know. You can come in, you can explore ideas. All of our partners are happy to supply expertise and equipment, and to try to get you to a solution. And consider us a resource. Then hopefully we can be a resource for designing and building your manufacturing equipment as well. Also just to touch on the diagram behind everyone there. If you're interested in exactly what it takes to set this up, that shows all the detailed interconnections and how everything fits together, if you're wondering about that.
We are ready for lunch.
We are ready for lunch.